Today we're going to review factoring. There's a few different techniques. So part of this review will be not only just the method of factoring, but also choosing the proper method and being able to find out which method that you're going to use. So let's go ahead. The first problem says factor 16w cubed minus 12m. This is the most basic form of factoring. This is factoring out the greatest common factor. And this should be tried on any problem that's asking you to factor or any problem that involves factoring. Try to factor out the greatest common factor. See what factor goes into every term in the problem. So we have 16w cubed minus 12m. We can see that 4 is the greatest numeric factor that goes into each term, and we don't have any variable common factor. So 4 would be the GCF, so we factor that greatest common factor out. And what we have left is, we have to ask ourselves, so 4 times what will give us a 16w cubed? So that would be 4w cubed. Because when you multiply whatever you factored out back through, you should end up with the exact same problem that you started with. So it wouldn't make sense to put a 2 or something else here, because if 4 times 2 wouldn't give you this 16. The only thing that would make sense is a 4. So 4 times 4w cubed would give us 16w cubed. Now, 4 times what would give us 12m? That would be a 3m. So that's one way to look at it. What do you have to multiply this GCF by to get the original problem? Or you can divide these terms by that GCF and it'll get you the same result. And that's the final answer. And we can check it. You can always check in a factoring problem by multiplying back through. So if we want to check this, I'm going to put the check in red. You distribute, so 4 times 4w cubed would be 16w cubed, and then 4 times 3m would give us 12m. That's it. The next type of problem is the difference of squares. But, like I said in the first problem, you always look for a greatest common factor between each of the terms. In this case, there's no common factors. So the next thing you want to look at is how many terms do you have? We have 2 terms. For 2 terms, we're specifically looking for a difference of squares or a sum or difference of cubes. So we don't even have cubes here, so the cubes are out of the question. So now this is a difference of squares, and the general rule for a difference of squares is if you have a perfect square term minus another perfect square term, it factors to the roots of each of those. So the root of a squared would be a, and then the root of b would be b squared would be b. So the addition and the subtraction. So that's the rule. So we do have 2 perfect square terms here. We can rewrite this 9 as 3 squared, and the w is already written in squared form. So if we want to factor it using the rule from the difference of squares, the root of this is already here. The root of 9 is 3. We showed that. So 3's would go here, and then your w's would go here, and then you'd have 1 plus, 1 minus. And it's important that you use the proper sign, because if you don't, when you check this problem by multiplying back out, you will not get the proper result. So when we check this, 3 times 3 is 9. 3 times negative w is a negative 3w. W times 3 gives us a plus 3w, and w times negative w is a negative w squared. The negative 3w plus 3w add up to 0, so that goes away, and our final answer would be 9w squared. So that would be correct. Next, we're going to look at factoring a trinomial when the leading coefficient is 1. The first thing you want to do always, like we said before, is to check to see if you have the greatest common factor. In this case, if we look at each of the terms, each term has a common factor of x squared. So we'd factor out the x squared. Well, it's going to make sense. Only thing that would make sense going backwards is an x squared being right here, because x squared times x squared is x to the 4th power plus 9x. If you're factoring the x squared out, it's like you're taking two of the x factors away. So if there was 4x's being multiplied, now there'd be 2. There was 3 here, so we pulled 2 out, so there's 1 left. And there was only 2 in this last term, so we pulled both of those out. So all that's left is the 20. After you factor out the greatest common factor, you always check inside of your parentheses to see if you can factor any further. And in this case, we can. We have a trinomial with the leading coefficient 1. These are not as hard. You have to look at this last term, the c term. Remember, we have x squared plus bx plus c. So we want to look for factors of c. So two numbers that multiply to give us c, but the same two numbers should add up to give us b. So in our case, we're looking for two numbers that multiply to give us 20, and we want the same two numbers that add up to give us 9. So 20 factors of 20, 5 and 4, 10 and 2, 20 and 1. We don't have to worry about the negative factors because our whole trinomial is positive, so that it wouldn't affect us. You can see that the two numbers that sum up to 9 that also multiply to 20 are 5 and 4. So to factor that, we would have x plus 5 times x plus 4. Just take the two factors. They're both positive, so you add them inside of the binomials. And that's the final answer. We could check this once again by distributing and then distributing the x squared, and we should get the same answer. But the checking process is the same for every factorization problem. Just multiply it back through and see if you have the same problem. Number 4. This is a type of problem that gives students the most trouble because its leading coefficient is not 1. And there's processes, I guess, that books or maybe even Alex will show you that's a lot of guessing and checking. So I just actually learned this new trick myself. It actually works out pretty well. So the first thing you want to do is you take the leading coefficient. So in this case where the leading coefficient is something other than 1, we have ax squared plus bx plus c. That's the form that we have. So 5 is where our a is, and the negative 9 is where our c is. So we want to find two factors of 5. We want to multiply 5 and negative 9. So 5 times negative 9 gives us a negative 45. So what we want to do is we want to find factors of negative 45 that sum up to this positive 12. So we have to start thinking about what that might be. If you think for a moment, you should see that you get a negative 3 and a positive 12. I'm sorry, 15. And they would sum up to 12. So when you work this problem out, this is a trick. So you're going to set it up just like this. It's going to be W and W, whatever your variable is. And you're going to put these two numbers that we just figured out into the binomial. So minus 3 and a plus 15. Then you're going to take this first term, this coefficient, 5, and you're going to divide each of those numbers that you just wrote in there by that 5. And it will simplify in some parts of the problem and other parts it won't. So if it simplifies, like in this case, 15 divided by 5, that just gives us a 3. So this is just going to be W plus 3. In this case, 3 and 5 don't simplify. So all you have to do is take this 5, move it up here to the coefficient, and that's your final answer. So 5W minus 3. And we can double check that by multiplying this out. So if we check this, 5W times W is 5W squared. 5W times 3 is 15W. Negative 3 times W is negative 3W, and negative 3 times a positive 3 is a positive 9. When we combine like terms, we see that 15w minus 3w gives us a positive 12w. And I said that's a negative 9, but for some reason I wrote positive, so minus 9. So if we just review that process one more time, we take the a and the c term and we multiply them. So we took the a times c, and that gave us negative 45. Then we look for factors of this number that we multiplied to get that sum up to this b term. So we wanted two numbers that multiply to give us negative 45 and summed up to give us a positive 12. Then after we found those two numbers, we just wrote them in with no coefficients on the w, and then we divided each of those numbers by that leading coefficient that's on the square term. So in this case it would have been 5. It simplified in this one, so we just brought that down. But if it doesn't simplify, just bring that bottom fraction up to the leading coefficient of this binomial here, and that is your final answer. Alright, this problem incorporates a few things that we just reviewed. First, we can factor out a greatest common factor. So in this case, 4 goes into each term, and so does x cubed. So 4x cubed is the GCF. We factor that out. That would leave us with a 3x squared plus 10x plus 7. In this case, our leading coefficient on the polynomial inside of the trinomial inside of the parentheses is greater than 1. So we can use that trick that we just learned. So we take the a and c term, so 3 times 7 gives us 21. So now we want to look for factors of 21 that sum up to 10. That's an easy one. Everything's positive, so we don't have to worry about negatives. So it's 7 and 3. So we have to bring this 4x cubed down. But then remember the trick. We put the x and the x. And then we put the two numbers we just found there. So plus 7, they're both positive, plus 3. So we get additions. Then we're going to divide by this a term, this a coefficient on each of the numbers we just wrote there. And to finalize this, 7 divided by 3, that doesn't go evenly, so we just move this up here. So it's going to give us 3x plus 7 times 3 divided by 3 is 1, so we have x plus 1. And that is your final answer. Next, we have factoring by grouping. This the key to figuring out when to use this one is it usually only happens when you have 4 terms. So you're not going to use grouping if you have 2 or 3 terms. It's usually a 4-term thing. You look throughout the problem, you can see that each of the terms does not have a common factor, so you cannot factor out a GCF. But you can group the 2 terms. There's 2 pairs of terms that have common factors. So you can group WU plus UV. There's a common factor of U in there. And then you can group the negative 5V minus 5W. They have a common factor of negative 5. So what you do is you factor out that common factor in each of the groups that you just created. So U is the common factor here. So what would be left? W plus V. And then negative 5 is the common factor in the second grouping. So we factor out a negative 5, and what we have left is V plus W. Which is the same thing. We could just reorder this. W plus V, V plus W, it's the same thing. Now we can see that we have another common factor. This whole binomial, W plus V, is the common factor. So we can pull that whole factor out. So that comes out W plus V. And what's left over is what you had outside of each of the other parentheses. So U minus 5. And that's our final answer. Another type of problem when factoring is you may have to factor multiple times throughout the problem. So you have to get in the habit of looking at what you have inside the parentheses after you factor, just to make sure that it's not any there's not any more factoring that can be done. So in this problem, first thing we can do is we can factor out the greatest common factor, which would be 2v cubed. what we'd have left is u to the fourth minus 1. Now we have a difference of squares here. This would be 2v cubed, and then our difference of squares, because both of these are perfect square terms, so this would be u squared minus 1 times u squared plus 1. Now let's look at each of these parentheses. We have another difference of squares in this u squared minus 1. So they're both perfect square terms, and there's a difference. We have a subtraction between them. So we can factor that a little further. 2v cubed, and this would factor to u plus 1 times u minus 1. And we bring down the u squared plus 1. The reason we don't factor the u squared plus 1 because the difference of squares specifically has a subtraction between the two terms. That's the only time we can use this difference of squares. So because of this plus, we can't factor that. Okay, the last type of problem that we're going to review is factoring the sum or difference of two cubes. So we have to remember the formula. So for the sum of two cubes, a cubed plus b cubed factors to a plus b times a squared minus ab plus b squared. And then the difference of two cubes is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So we're going to apply this in this problem. You're going to have to practice to be able to recognize perfect cubes. In this case, we have two perfect cube terms. And we can rewrite this first term as 3y cubed, and the second term is 5 cubed. So in our case, a would be 3y, and b would be 5, and we have a sum. So we're going to use this first formula. So if we want to factor this, it would be 3y plus 5 times a squared. So 3y squared would be 9y squared minus a times b. So minus 3y times 5. So minus 15y. And finally plus b squared. So 5 squared would be 25. Once again, you can check this by multiplying this out. And you should get the same thing that you started with. And we can go ahead and check that now. So 3y times 9y squared give us 27y cubed plus 75y plus 45y squared let me restart that. (27y cubed minus 45y squared plus 75y. Then we would have a plus 45y squared. Just writing it to line them up so we can see where to add easily. Minus 75y plus 125. And when we add those up, we should get 27y cubed plus 125, because these would cancel out, and we are done.